Iniziare. Buongiorno a tutti, spero stiate tutti bene. Sono Deborah Bazzi, Product Manager del Dipartimento Food di Prodotti Gianni e vi volevo dare il benvenuto a questo webinar che svolgeremo in collaborazione con la nostra rappresentata Fiberstar. Fiberstar è un'azienda americana specializzata nella produzione di fibra di agrumi ed è partner di Prodotti Gianni da diversi anni, con il contratto di esclusiva per la distribuzione sul territorio italiano. La conferenza si svolgerà in inglese ed il relatore sarà Stefanos, il nostro referente di Fiberstar, che vi illustrerà le caratteristiche della fibra di agrumi Citri-Fi e i vantaggi applicativi in prodotti da forno e semilavorati a base frutta. Se avrete domande durante la conferenza avrete la possibilità di formularle in due modi, o in tempo reale scrivendo in chat, oppure nei momenti che Stefanos dedicherà alle vostre domande. Alla fine del seminario vi inoltreremo poi la presentazione e il video del webinar. Ora vi prego di spegnere i microfoni in modo da evitare rumori di fondo durante il webinar. Quindi buon seminario a tutti, vi lascio con Stefanos. Please, Stefanos, we are ready, you can start.
Buongiorno a tutti.
Good morning. Thank you for joining this webinar. My name is Stefanos Psilopoulos. I'm Technical Sales Manager of Fiberstar in Europe. Fiberstar is a US-based company producing citrus fiber, is a citrus fiber specialist. So I will start with a few words about Citri-Fi. What is Citri-Fi? So it is created using a patented technology that opens the fiber up to create a natural high water holding capacity and emulsification properties, which are applicable to multiply food applications. It's a clean label product, allergen-free, non-GMO, chemical-free. The labeling is really friendly. Most of the time we use the word citrus fiber, and Citri-Fi also works synergistically with other hydrocolloids like starches and gums to provide additional functionalities, improve the nutritional profile, and offer potential cost savings. But the main reason to use it is to clean up the labels, replace or reduce chemical ingredients, allergens, and ingredients with a negative impact. So Citri-Fi is created by procuring byproduct from the juicing industry. This is citrus fruit that is created by mechanically opening the citrus, the fibrous cell wall material. This process loosens and opens the tightly bound soluble and insoluble fibers and proteins to create an expanded fiber matrix. This material is then dried and milled into a free-flowing powder. This is a cross-section of an orange and its main components. Some of these components are what go into the process to make Citri-Fi. As you can see here, this graph shows what citrus material looks like before and after. So before it is processed using this patented technology, and after the material is passed through the process, the fiber is opened to create a high surface area that provides this high water holding capacity. So Citri-Fi contains about 75 to 80% fiber depending on the product. The fiber is half soluble, which is mainly the pectin from the fruit. It's half insoluble, and there is also a part of the protein. Okay, so the soluble fiber, the pectin, attracts the water and provides viscosity to the product. The insoluble fiber provides a structure to hold the water in the product, and the protein with the soluble fiber provides emulsification properties. This is our product range. The 95% of the applications is we are using the Citri-Fi 100 series. It's our top product and the product that we are mainly using in Europe. It's a clean label citrus fiber, and we have 4 different available grinds. It depends on the application. We choose the the right grind. There is another one product, the Citri-Fi 150, which is also a clean label citrus fiber, but it's less functional than the 100, and there is no emulsification properties. So it's mainly specific applications that we are using this fiber. We just developed another one, the Citri-Fi TX10, which is a coarse texturized citrus fiber. The reason that we developed that fiber is the meat alternative products in order to use it with other texturized vegetable proteins. And there are another two products, the 200 and the 300. Those two are not anymore clean label. The 200 is the 100 product co-processed with guar gum, and the 300 is co-processed with xanthan gum. Okay, so we should label the guar gum and the xanthan gum when those two products are used. This is our grinds. Every product have different grinds. So the Citri-Fi 100 is around 600 micro. The 100 FG is 150, and the 140 is 75. We choose the right particle size according to the application, the mouthfeel, the process. So, few words about the functional properties of Citri-Fi. Firstly, we will talk about the water holding capacity. Citri-Fi tightly holds high amount of water in food products in a wide range of conditions. So we can hold around 9 to 10 times its weight in water. This video shows a demonstration that we are doing in order to show how Citri-Fi works. So it binds the water really fast. You need just few seconds in order to start binding the water. And in 5 minutes, it's fully hydrated. This graph shows that in 5 minutes, the fiber is fully hydrated, what we said before, and it can hold, one part of fiber can hold 10 parts water. This graph shows that with just 30 seconds high shear, we can boost Citri-Fi functionality, we can increase the water holding capacity, and it also shows that temperature does not affect the water holding capacity. In general, Citri-Fi is a quite heat-stable product. Even in baking conditions in really high temperature, it can be functional. So, about high shear, this is a simple example in a Thermomix that shows how Citri-Fi is affected when we are using high shear. Okay, the figure 2 shows just Citri-Fi with sugar in water, 7.5% Citri-Fi in water, without shear, and in figure 3 is after a couple of minutes high shear. Also, the high pressure homogenization can affect a lot the water holding capacity. So in case that we have it in the process, that can boost Citri-Fi functionality and increase the high water holding, the water holding capacity and the emulsification properties. Those photos also show how the homogenization can affect the water holding capacity and the viscosity. It shows what happens at 100 bar, 200 bar, and 300 bar, and how the viscosity is affected. So we discussed that Citri-Fi is a quite heat-stable product, but it's not also sensitive to pH, cooking salt, and calcium. That makes it unique compared to other fibers in the market, that they are not as stable as Citri-Fi. So you can see that the water holding capacity does not change when we change the pH or when we add salt or when we are using hard water. So Citri-Fi has a very high water holding capacity with excellent stability. This table shows that Citri-Fi can hold, the 100 product can hold around 10 times its weight in water. The 200 can hold around 13 times its weight in water. And compared to other fibers like carrot fiber, wheat fiber, and cottonseed fiber, the water holding capacity is much higher. This is another graph, another table that shows the water holding capacity of Citri-Fi compared to other citrus fiber, but the interesting thing here is the gray bar that shows how many ml of water 1 gram of fiber can hold in a cooked meatball. Okay, so it shows the heat stability of the product. And if you compare the heat stability of Citri-Fi compared to wheat fiber or potato fiber or soya protein isolate or in general other fibers, you will see that Citri-Fi is much more heat stable than the competition. So about the emulsification properties of the product, this video here shows that Citri-Fi can bind water. This is just 15 ml of oil, and we add 5 grams of Citri-Fi into the oil in order to avoid lumps. We just mix it a little bit. And then we add around 35 to 50 ml of water and mix it. Citri-Fi binds really fast the water and the oil and provides emulsions. In this video, you can, I don't know, take some time with the videos. Yeah, it takes some time with this video. It works. So in this video, you can see the same experiment. We just use colorants. The blue one is the water. We add the yellow that it's the oil, and we have already added Citri-Fi in the oil, and we just mix it with a stick. No high searing, no high pressure. We just mix it with a stir. You will see that viscosity will start increasing, and Citri-Fi will bind the water in the oil, and we will provide a stable emulsion. So as mentioned, Citri-Fi provides excellent emulsification properties, and this test that you see here creates emulsion using various emulsifiers and stabilizer. So after hydration, the emulsion were mixed with some CR and then centrifuged, and we checked how many grams of oil per gram of stabilizer we can have in order to create a stable emulsion. So you can see that Citri-Fi can create stable emulsions with more oil than compared to oat fiber or lecithin or monoindiglyceride. High searing also helps a lot to create stable emulsions. CR effect open the citrus fiber to create additional stabilization for food. It reduces the oil droplets, enhance the water binding of Citri-Fi, so increase the physical surface area for oil binding. This is high pressure is really important if we want to have really stable emulsions that during the shelf life of the product. Any question until now, because we will start talking about specific applications. If you have any question, you can type it in the meeting chat, or you can just...
Stefanos, Lorenzo Tanzi speaking, Head of Food Lab, Prodotti Gianni.
Good morning.
Good morning, hi. How are you?
I'm fine.
Just a clarification. Talking about pressure in use of Citri-Fi, I saw that all the high pressure give us a higher texturization property to the final mixing of Citri-Fi and water. Do you have some example to comparison of using Citri-Fi in final product? An example, UHT beverage and something like that about this effect of the pressure in the final product. So if
I
don't
we
know
have
if
many.
clear the question.
Yeah, just to show the effect of the high pressure in the product, but that would be in mainly in products like beverages, dairy products, and how it works, right?
Yeah, okay. You don't have at the moment some example to show us?
I can show. I don't have it in this presentation, but for sure we have.
You can share it.
Yeah, of course, of
Great,
course, of
great.
course, of course. It's mainly high pressure. It's mainly, I mean, the need of homogenization pressure is really needed in products, for example, like dairy alternatives, plant-based drinks, juices, dairy products that we anyway are using high pressure, so it can boost the Citri-Fi functionality and create stable products. Okay.
Yeah, all range are very interesting at the moment on the market.
Yeah.
Great. Thank you very much.
Yeah. So there is another one question: if Citri-Fi is suitable also for fat-based fillings? Of course, and it's suitable for fat-based filling. You can use it as an emulsifier. We just need a little bit of humidity in order Citri-Fi to be functional. If it's 100% fat, it will not be functional. So we need a little bit of humidity. Even 1% or 2% will help. Or if there is humidity from other ingredients, that will help Citri-Fi to become functional and stabilize the emulsion, create viscosity, provide texture to the product.
Stefanos, I have another question. Vincenzo De Tata from Barilla.
Yep.
What about temperature? We have seen in one chart the heating at 80 degrees.
Yep.
But what about 100 degrees or more?
The graph, give me one moment. Citri-Fi can be in order to have stable emulsion or in order to keep the water in the product?
In order to have a stable emulsion.
We've seen that we can go up to 90, 100 degrees and to have stable emulsions. If you go higher, you can have some problems with stability.
Mm-hmm. Okay. And so are we talking also about shelf-stable products, ambient stable products, which can have also a life of 1 year, for example?
Exactly, exactly.
Okay, thank you.
I don't see any other questions, so I will go back to the application. So this is some information from Innova database. So global product launches with citrus fiber on the label the last 3 years. You can see that in bakery, most of the products globally that are using citrus fiber the last 3 years are bakery products. It's a trend. It's something that it's growing really fast, and it's one of our top applications right now, top segments. So the reason to use Citri-Fi in the top bakery application benefits is to first to improve the freshness over time. Because of the high water holding capacity and the oil binding, we promote the moisture retention in the product. It's the stability, does not break down and continues to hold the water and fat over time, even in harsh conditions. Clean label declaration, of course, as I said, Citri-Fi is a totally clean label, natural ingredient, so we can replace ingredients such as modified starches, gums, chemical emulsifiers in the products, all allergens. And in nutrition, we can partially replace fat, oil, or egg to reduce the calorie content and add fiber and reduce cholesterol in the product. So there is a wide range of products like cakes, muffins, bread, in fillings, in pastries, laminate dough, and tortillas products or pita bread that Citri-Fi can be used for several reasons. There are 3 ways to use Citri-Fi in bakery. The first one is to use it in order to bind or to add extra water in the product, so to increase the moisture in the product and increase the freshness. The second way is to replace a primary ingredient, partially replacement, that can be the oil or the egg. And the third one is to clean up the label. You can replace other ingredients, chemical emulsifier, what we said before. There are 3 ways to use it in bakery. Okay, the 99% of the time in bakery, they just dry mix it. They dry mix it with the flour and they follow the process. They don't change anything. You can even high sear it or homogenize the product into the water or in another liquid and use it in your recipe, but it's not necessary for bakery. If we are talking about fillings, it's very important to do it in order to stabilize the emulsion, or you can add it in oil in order to avoid the lumps. Okay. In general, what we recommend is when you add it in the water to add it under high searing, because you can get lumps. Otherwise, if you cannot do it, just add it in the oil. So the first reason is to improve the freshness over time through the shelf life of the product, increase the yield when Citri-Fi is used and extra water is added. To improve the texture in the eating qualities, Citri-Fi can help to increase the shelf life and improve the handling of the dough or the reduction of the moisture loss from the existing formula water. What we recommend is the, what we recommend is a usage dosage of 0.25 to 1% of Citri-Fi and 3 to 8 times extra water per weight of Citri-Fi. So I will show you some examples. This is a sandwich bread that we are using the 100. Give me 1 minute because I cannot see my screen. We use the 100 FG at 0.6 and around 5 parts of extra water in order to increase the humidity in the product and to improve the freshness. Okay, so you can see here that during the shelf life of the product, the moisture loss over days is less when we are using Citri-Fi. We started with a higher moisture and we end after 4 days with a still higher moisture. This is another study for cookies. Here we use the 200 FG. This is with the guar gum. You can do it with the 100 FG. Just with the 200 FG, we can even hold more water compared to the 100 FG, but we have the guar gum inside. 200 FG was used at 0.5 and we just add a 0.5 extra water. So we increased the preference of the product and we decreased the roughness and the hardness after a few days. The same way you can use it in gluten-free bakery in order to improve the moisture retention, tender bite, the natural emulsifier, to use it as a natural emulsifier, to increase the strength and the structure of the dough through the shelf life and or the product. And it's an easy to use product. So what we are using here is the 100 FG at 0.5%. We don't add extra water, we just add it on top in order to improve the freshness and the quality over shelf life So after 10 days, we can improve the mouthfeel. We can keep the same body as the day one, the craftbeerness, the flavor, and the color, compared to the product without Citri-Fi. I just checked that there is another one question. If Citri-Fi 100 FG can avoid the migration of the humidity from the middle of the biscuit to the surface in order to avoid the breakages. We have customers that they are using Citri-Fi for that reason, in order to keep the water from the middle not to go to the surface exactly that way. I don't think that I have something here like this, but yes, you can use 100 FG for that reason, and to improve this migration, the humidity migration in the product. So another application is the egg reduction. Normally, we recommend to use the 200 FG or the 100 FG. With the 200 FG, you can go up to 20% partially egg replacement. With the 100 FG, you can go up to 15%. The ratio is around 1 to 15. And this is an example in a cake that we reduce 20% of the egg in the recipe with a 200 FG, 1 part of fiber, 15 parts of water. So what we have seen is that we can keep the same numbers compared to the full egg control in terms of baking losses, same, and to improve the volume of the sample. If you check the graph with the moisture retention over time, we have more humidity in the product, and we can keep it during the shelf life of the product. And also the sensory evaluation, I would not say that it's improved. I would say that it's exactly the same as the full egg control. There is another one question. If we use this kind of fiber, also the water activity is affected or not? No, water activity we've seen, we have made tests, and we've seen that the water activity, if you use the right ratio, it's not affected. The water is still binded, so you keep the same water activity. And the third way to use Citri-Fi in bakery products is for partially replacement the oil or the fat in the product. We recommend to use the 100 line with a ratio of 1 to 7, or the 200 line with a ratio of 1 to 9. You can go up to 25% or 30% oil replacement without any problem. This is an example in a muffin that we replace the 25% of the fat with using the 100 FG, 1 part of fiber, 7 parts of water. And you can see that we can improve the moisture retention over time, and the sensory evaluation after 7 days, it's exactly the same as the control. So the last one is to clean up the labels. Citri-Fi, as we said, is a very good emulsifier, so we can replace some emulsifiers like monoindiglyceride and lecithin. We have made some tests to replace the monoindiglyceride in muffins and cakes. So in this example, in the control, we are using 0.57 of monoindiglyceride, and we replace it with 0.4 Citri-Fi. And in the graph below, you can see that after 12 days, we can improve the overliking, the moistness is improved, the hardness is, I would say, the same, and the springiness is also improved. This is the same, but we replaced the lecithin. Unfortunately for that trials, I don't have any numbers, any results, but we've seen the same more or less results using to replace lecithin. So lecithin was used at 0.4 and Citri-Fi 100 Fg at 0.58, and we had more or less the same product. Any question? Okay. So I will continue with the fruit applications, fruit fillings. As I said, Citri-Fi contains around 75 to 80% of fibers. The half of that is the soluble fibers, which is pectin. Okay, it's more or less pectin. It's an HM pectin that we can use it in fruit preps in order to provide baking stable fillings. So in order to have a heat stable gel, we need minimum 55 bricks in the product and the pH lower than 3.5. Here shows that how the pH affects the gel strength of the product. So we have a 60 bricks fruit prep, and we change the pH from 3.7 to 3.2. I would say that at 3.2, 3.3, we can have quite stable, heat stable gels. And this graph shows the gel area. So you can see what happens if you have a 50 bricks gel. You need to go too low with the pH in order to get some kind of gel. And you've seen that it works quite nice if you go from 55 or higher. Okay, for example, if you have a 60 bricks, you don't have to go too low with the pH in order to get a really strong gel. This graph also shows how the dosage of Citri-Fi affects the gel strength of the fruit prep. So we go from 0.5 to 2% Citri-Fi in a 60 bricks fruit prep with a pH 3.2. And you can see that we can even double, if you go from 1 to 2%, we can even double the gel strength of the product. So pH value and sugar not only affect the gel itself, but also the gelation time. So together with the University of Berlin, we studied this effect by using a special equipment to measure the viscosity during the cooling process of the hot fruit preparation. And in the next table, you can see that increased sugar and acidity causes a higher gelling temperature. This is important to know, especially for high brick system. And a buffer system can help if you are filling at lower temperature to avoid having pre-gelation in your cooking vessel. Also, we discussed about the different grinds of Citri-Fi. Using a different grind can affect the mouthfeel of the fruit prep. So with the 100, the coarse one, we get a very pulpy mouthfeel. With the FG, it's a pulpy, fine mouthfeel, and with the 140, it's a very smooth, creamy mouthfeel. Most of the time, for the baking stable fruit preps, we are using the 100 FG or the 140. The way to use it, it's quite simple. You just blend it with all the dry ingredients, normally sugar and acid, and you follow your process, or you can dry blend it with just sugar, 5 to 10 times sugar. It's up to you. You can even disperse it in sugar syrups or to do a hot dispersion in water or cold dispersion. But the most easy way, and we get quite good results, the best results is when you add it with the sugar or sugar and acid together. So you can use Citri-Fi in fruit spreads and jams and jellies, but mainly it's for bakery products because it's a heat stable. We can create heat stable, baking stable fruit preps. This is an example in a bakery fruit filling that we have the control that is just with pectin. This is a 72 bricks fruit prep. And we can partially replace a part of the pulp of the apple puree, reduce the pectin, and add Citri-Fi. And the third sample is just with Citri-Fi, no pectin inside, and reduced pulp. So at the same time, we partially replace the pectin, or let's say extend the pectin. In the third sample, we just replace the pectin and reduce the pulp. So we have the pre-bake products that looks the same, and we have the post-bake products that it's also the same. So we have a clean label, heat stable fruit prep, and in some cases it can be also cost effective because of the price of pectin. It depends on the bricks, on the pH and the dosage. The more bricks, we can reduce the Citri-Fi dosage, so it can be cost efficient. So just to, it's an easy to use product. We don't require any calcium. It can be filled hot. It's pumpable and provides synergistic benefits to other hydrocolloids. And you get a natural appearance and bite. And of course, it's suitable for clean label and natural products. To summarize, Citri-Fi is a natural non-GMO product, really easy to use. It is labeled as a citrus fiber, dried citrus pulp or citrus flour. In Europe, I would say that the 99% of the cases, we just label it as a citrus fiber. There is also the option to label it just a plant fiber or fruit fiber or vegetable fiber, but you should check it with the local legislation. Citri-Fi contains around 40% native pectin, that it can be used in fruit preps, but we need at least 55 bricks and a pH lower than 3.5. We get a gel strength, and the gelling time can be targeted by adjusting the bricks, pH, or Citri-Fi usage. And Citri-Fi is available in several particle sizes, which allows to target specific textures. So this natural ingredient creates a natural-looking fruit texture and can replace ingredients that can be gummy. So just any question? No? Okay. So just for the end, we will check some commercial products in the market just to understand where Citri-Fi is used. So this is a product from Poland, but it's Poland, Germany, okay? That was launched in Poland. It's a gluten-free bread. All this information is from Innova database. So Citri-Fi 100 FG was used in this product. No, sorry, citrus fiber. Right? It's not Citri-Fi. Citrus fiber was used in that product to improve probably the humidity, the water retention, and to improve the shelf life of the product. This is another one example from the same company. This is some cinnamon rolls. Probably citrus fiber was used in order to improve the softness of the product and to extend the freshness. This is something like biscuits with fruit prep. So citrus fiber was used in the fruit prep as a jellifier with pectin. The same thing here. This is a biscuit with apricot flavored filling. So citrus fiber probably was used along with pectin as a jellifier. These are some cinnamon biscuits. Citri-Fi was also used this product. This is some baked cookies. Probably they used citrus fiber to improve as an emulsifier, but also to improve the freshness of the product. And that's it. Any questions?
Stefanos, Laura speaking from Prodotti Gianni.
Yep.
Just to advise you that you have a lot of questions in the chat. Okay.
So we talked about to avoid the immigration of the humidity. We talked about this, and if the water activity is affected, we said that it's not affected. If you use the right ratio and you can bind the free water. I don't see any other question. I don't know why. I don't see any other question.
Yeah, hi, Stefanos. No, I think you can go on. Thank you.
Yeah, that is for the bakery. If just to let me go back. So no, we are almost finished. I mean, if there is any question, if we need to check anything else, I can show it. No, I don't see any question. So I will just give me. Just give me one moment to find something about the first questions from Tanzi. I don't know if you can see my screen. It's for the first question about how the high pressure and the effect of homogenization works in the product. This is an example in an almond milk. Okay, so it's something different, but just shows how Citri-Fi works if we have the high pressure. So we have the first sample that it's just an almond milk, clean label, no gums inside, nothing, with just 0.25%, 100 M40. That it was homogenized at 150 bar, and the sample on the right is just almond milk, again with Citri-Fi, but not homogenized. So as you can see, you have a phase separation over time that goes by protein. when you don't homogenize it and you have sedimentation of protein and fiber. So this is the way that the high pressure can boost Citri-Fi functionality and provide stable products. Okay. If there is any other question, I'm here. Otherwise, I think that we are okay. Deborah?
Thanks, Stefanos. Thanks all for the participation to the webinar. I would like to remind you all that we are going to forward you the presentation of Stefanos and also the video of the webinar. And that's it. Thank you very much.
Thank you for attending the webinar. Thanks a lot.
Thank you very much. Very interesting.
Thank you.
Bye.
Thank you.
Bye.
Thank you. Have a nice day.
Thank you.
Thank you. Bye-bye.
Thank you. Bye-bye. Have a nice Easter.
Okay, so